Okay, so this is the beginning of lecture 3.3, which is going to be about continuous integration. But before we get into that, talking about the leaderboard, there's a link in the spec for it. Originally, the plan was to run it Wednesday, Thursday, Friday, Saturday, Sunday night. However, we remembered because it's due on Monday, running it overnight Sunday is not going to be super helpful because you're not going to have all this time to work on it. So we wanted to give you 5 chances. So instead, we're going to run it Tuesday night, Wednesday night, Thursday night, Friday night, Saturday night. In effect, this means that for the morning, it'll be available. Now, we also realize that the problem is many of you probably stay up late, not all of you, and therefore running it at midnight or whatever, some of you are going to be scrambling in. So Emily and I decided that let's just actually run it in the early morning instead of at like midnight or something. So what that has essentially meant is that when we're running it is Wednesday morning, Thursday morning, Friday morning, Saturday morning, Sunday morning, 5 times in the mornings, typically around 10 a.m. But let's actually have a look at the leaderboard. I haven't looked at this, so Emily and I did some tests on it last night on Monday, so hopefully it works. Yay, it's there. It's all good. So, what this is, every group was given an alias, and this was emailed to you. If you didn't get the email, it's likely that someone in your group got the email. So please talk to your group, because I understand a few people would have changed groups and enrolled late, but 99% of you got an email from me saying, here is your alias for your group. So check your email is the short answer. In terms of this, what this is iteration 1 here, which we're on. It tells you the last time it was run, or last time it was uploaded. It's actually run slightly before that. So Emily ran this at 10 a.m. today probably. It uploaded it at 10:40, about 50 minutes ago. And what you can see is this is a group alias. This is the name of a group. This is an actual class. And this is their rank amidst all of you. This is their commit hash. This is the commit we ran. This one's really important because the way the auto marker works is it doesn't like pull all the code at once and then run everyone's like a specific time. What it actually does is it pulls one at a time and then it runs it. So what that means is that some of your groups here, your code was pulled from master and run at 10 o'clock. Some other groups it was pulled at 10:20 or something like this. So rather than be confusing and all this stuff and be like, what time did we do it? We just run it at the time we say, which is typically going to be 10 a.m. And then we just tell you the commit hash we ran. That's it. So like when you go to your master, you can go and look at this commit hash and be like, okay, that's the one they ran. So you can be like, this commit's the one that got those marks. That's just to remove confusion. This is the mark you got for running your own tests against your own code, which means this group, like many groups, all of their tests pass their code. This is the mark you get from us running our tests against your code. So this is how we tell how good your code is, because we ran our tests against it. So this top group here, Drain Destruction, they got 98.77% as their score, their T score, I score, sorry, to their implementation, and then their final score, which is the product of the two of them, is 98.77. So what this means is that this group here has got 98.77 as a auto marking mark for iteration 1. This is the mark you'll get given right now if you didn't submit any more code for the auto marking component. Iteration 1 is meant to be a little bit easier too. So this is quite hard. Oh, it's not too bad. If you go through this page, you'll start to find your group eventually. You know, we got fight, field, conscious cell. I removed some that were a bit weird. There were some just strange ones. Like there's funny ones like Fastberry, Memo Dragon. There were some weird ones that I was like, that's probably not great. But if I missed Giraffe, Bruise Winter, Program Baby. These are random word generators, by the way. I didn't write these out. So anyway, you can see how your group performs. Now, I just want to be clear. It's pretty reasonable that a group a few days out, like 5-6 days out from due, 5 days, is getting like 40%. Okay, like I wouldn't stress about that at all. Some groups are just working faster. It's one of those things where your mark kind of inclines pretty aggressively towards the end, because everything comes together, you sort stuff out. So, and then, we have at the very end, we've got a bunch of groups getting 0. Some groups are getting 0. A lot of these are probably compile errors in their PyTests, I would guess. If you get 0, you get 0 altogether. Cool. Waleed says, is there any way to look at what we're lacking in, talking to tutors or something? Oh, I love that question. So, is there a way to figure out what you're getting wrong? The short answer is no, because what's really like, so good computing education generally follows a pretty straightforward principle, which is like, you give someone a problem, you give them a couple of tests to help them sanity check it, but beyond that, you don't give them the tests you run until you actually mark them. And the reason for that is because once people get like tests that say they get the marks, their focus stops becoming on writing good software and their focus starts to becoming on passing the auto marker, right? And that makes people, generally speaking, program the wrong way, not the way we want them to. In terms of this, we also kind of acknowledge that there's a certain scary element about writing all this code and then the auto marker just gives you a mark and you're like, oh crap. But by the way, there's a next button down the bottom here, just right there. Yeah. You know, the auto marker just gives you a mark and that's really scary, and it's also not as fun. So the compromise we made was pretty simple. We'll give you a leaderboard. We'll run it a few times, because if you could run it every hour, even if you couldn't see why you failed, you would just be like making random changes all the time. You'd be like, you wouldn't be thinking properly, right? You'd literally just be trying to converge a mark. So we run it 5 times per iteration. That's enough that you won't try and like test stuff with the leaderboard, right? You'll keep trying to write good code, and the leaderboard just helps you figure out if you're in the right direction. The other thing is we don't release tests to you for that same reason. So the leaderboard's your mark. You know, if you go to your tutor and you say, why have I lost marks here? They're just going to put their hands up and say, I don't know. That's not what the leaderboard's for. That's for you to figure out. If you've lost marks, you need to write more tests. Write more tests, read the spec again, because most of the time that you've lost marks, it's either because you haven't implemented something yet, you've implemented it, and your tests are, you either haven't implemented it yet, you've implemented it, but you don't have enough tests to tell that it's broken, or, what would you say? Or the other one is that you have implemented it, written tests, your tests are passing your implementation, but you've misunderstood the spec. You've like misunderstood that. So, you know, go read the spec again, go check your tests again, go make sure you've implemented anything. Again, please, if there's any group names that are bad and on your group doesn't like, more specifically, if your group has an alias that you don't like or one person in your group doesn't like, please email me and I'll fix it up. I'll change it to something else. You won't get to pick, but I remove some of them. You know, it's fine. Just email me if there's a problem. Okay, so that's the leaderboard. Good fun. Check back here tomorrow. We'll tell you when we run it. It'll be run sometime between 10 and 12. That's about it. And Rohan says, are these tests only run on our master branch? Yes, we pull your master branch from your repo and we run the code on that, and we'll run it sometime typically between 10 and 12. So consider like 10 a.m. your time that you should have everything you want in there for. I'd probably recommend generally, unless it's like not urgent, trying not to put any merge requests into master between 10 and 12 unless you think they're necessary, because you know, it might break something, and you only get 5 chances at this. Anyway, I've talked about this plenty. If you have any other questions, post them in the chat. We might answer them. Otherwise, you can post in the forum. We're going to get into this next piece on continuous integration, because it's quite interesting. Okay. 3.3, testing, continuous integration. Why? What are we talking about and why? So, when you're working on groups, like your project, to scale these multi-user groups, because you imagine like companies like, you know, Google, Atlassian, all these companies, they're big Git repos with lots of people working on them. And you need ways to automatically integrate code and make sure it works. You know, now you've actually already been doing this in this course so far with things like the pipelines and PyTest running. So you've actually kind of had an experience of this, but it's time to talk about what it is more theoretically, more generally. But we need automated ways to integrate code. Could you imagine for a second if you were doing your major project and you didn't have PyTest and the pipelines? Every time you push code, someone's probably going to make a mistake. well, they're not probably gonna, there's a probable, there's a likely, there's a possibility that they make a mistake, and there's no kind of centralized automated way to make sure that code's functioning. So what we use to solve this problem, what we use to make code easier for many people to merge into master and maintain that, is a notion of continuous integration. Continuous integration is the practice of automating the integration of code changes, basically merges into master from multiple contributors, your group, into a single software project, your Git repository. Yeah, so Blake's, I think I just answered this and there's lag, but Blake's asked the question, what's meant by integrating here? It's the merging of code into master, right? So basically, integration is like, think about, merging code is really integrating it all into master. Now, what does this look like conceptually? Well, continuous integration conceptually, you can view it as something like this, where you write some code, you're happy with the code, so you get it approved, it gets merged into master, and then what happens is that it gets built, it gets tested, and then you get a report on it, which is, and you imagine for a second, what are these three steps? Build, test, and report. Well, build isn't really applicable for Python because you don't build Python. That's more for C or other kind of compiled languages. So you can kind of pretend that one doesn't happen in the Python sense. Test is when you run PyTest on it. So when you push your code to master, the GitLab thing will test your code by running PyTest, and then it will report to you with the tick or the red cross about like what's happened. And then you might go and fix some other things up. Once you're happy with this, once you've and continuous integration's there to make sure your code works, once that's all good, you can maybe then release it. And we'll talk about releasing stuff later in the term, around week 7 or 8. But for now, it's essentially the topic of how to seamlessly and automatically make sure that the code merged into master is stable. Stability is the key thing here. It's to make sure that everything's always okay. We do cover deployment and release in CD and 1531 as well. It just comes up later because it's not critical right now. Oh, I meant to remove this slide. Damn. You can ignore a little bit of this slide. In fact, I'm going to get rid of it, so I'm sorry. I thought I removed this last night. I looked at it and said to delete it. I think it was the last thing I did before I went to sleep. So basically, this slide used to be in a different place in a different order. But the main thing to take away from this slide at the moment is that the point of continuous integration conceptually, again, is that you always want to make sure that you have a green tick on master. And ideally, you don't merge your code into master until your branch has a green tick as well. So these green ticks are really important, and a green tick is like a pass or a fail for your code as it stands. What determines that pass or that fail? We're going to get into that in a sec, but generally it's a whole bunch of stuff. It could be testing, it could be linting. We're going to learn about coverage tomorrow, so it could be about that as well. So there's tons and tons of stuff it could be about. And like just as an example, no, I'll talk about my example in a sec because it'll make more sense. Yeah, sorry about this slide. I mean, it's not bad, it's not wrong. It's just some of it's a bit confusing because it was in a different order. So how exactly does continuous integration work? Well, I mean, again, you understand it in a tactile sense. You push code to GitLab, GitLab runs your code, and it passes it or fails it. But what's actually happening there? Does GitLab run your code? So typically what happens with these, like Git software, is that their continuous integration processes, GitLab itself manages the continuous integration checks, but it actually outsources the running of that code to what we might call a runner or a job machine or some kind of external something, which is basically an application that tests your code for you. It's like an external server. How that looks, we'll come back to this slide. How that looks is actually something like this. So you have all of your different group members in different groups, all the people in this course. You have 140 different group repositories between you, and in terms of labs, you have 35,000 labs, is it? I think you have 35,000 GitLab repos between you all, and all of those, 150 project repositories and 35,000 lab repositories, they all actually use the same computer. So there's actually one computer sitting there in CSE that's actually running all of your PyTests for you. So you know, when you push code, whether it's on your branch or whatever, all this code's getting stacked up in a big queue. And then there's this computer in CSE, which we call the runner. Its job is to run code. It's an actual, think of it like a literal laptop sitting in CSE. It's not a laptop, but you get the point. It's just a computer sitting there doing nothing all day except running, you know, jobs to check code. It's just running through a queue. And that's why sometimes you'll see that the GitLab pipelines go quick sometimes and sometimes slow. So during busier periods, they go quite slow because there's a big queue. There's a big backlog of things to do. Now, this is an important note because when it comes to your project being due or even your labs, we always get students every term who are trying to write a lot of code at the last minute. And sometimes the GitLab runner might take 10 minutes to run. Be 10 minutes in the queue before it can run. And then they say, you know, oh, this isn't, you know, I need extra time and stuff. And it's like, it's a little bit annoying, obviously, but it's also important to remember that in this course, all of our runners only run things you can do locally. So like even right now, when you run, when you get the little pipeline run, it's actually just running PyTest in most of the labs and stuff you've seen so far. And you can run PyTest locally. Like I'll show you the command in a second. It literally just runs PyTest. It's very straightforward. So back to this here, there's this idea of this runner, and the runner actually does the work for you. So GitLab connects to a runner in CSE, and that runner does the work for you. Different Git providers have different models with this. For instance, Bitbucket has runners built into it. 1531 GitLab doesn't. So GitLab doesn't have runners built into it. So you kind of have to make an external one. And when I say Bitbucket has runners built in, I don't actually mean like it's built into the Bitbucket website. It's more like the Bitbucket product. I think GitHub does the same thing. But it just like you can sign up to Bitbucket and actually they'll actually give you some space on a shared runner so you can actually do some continuous integration on your code. Now in terms of how this pans out practically, there's some reading here which I'd recommend you should read. There's just a few short articles. But let's actually talk about this practically because it's like, okay, continuous integration, sure, you merge code, there's a pipeline check, passes, fails. That's how we make sure our code's always working. Okay, how do we interact with that? Well, let's go have a look at your major project to start, or even, you know, even better. Let's go here and let's make our own little repo. I'll call this like CI demo. We've got 10 minutes left. It'll be plenty of time. So I'm going to make a repo called CI demo, and we're going to test that out ourselves. CI demo. I'll create this repo. It's just for me, and I'm going to clone it in GitLab. And we'll go inside that folder. And then what we'll do is we'll go and have a look at our project. So if you go and have a look at the project, right, you'll see that your project actually has a few files in it in here. The file on GitLab that determines what continuous integration things happen is actually this file here, the .gitlabci.yaml file. What this file is this is a set of GitLab compliant instructions that tell GitLab what steps should be taken when you push code up. It's basically the continuous integration instruction file. And it's really quite simple. Like it's short. Some of this won't make sense, and it's a little bit weird how it's laid out, but this is what GitLab actually uses. This is in all of your repos, all of your labs, all of your project. So whenever you upload code, GitLab is like, I see. You want me to do this. Now in this case, what this one is referring to is this is the particular computer in CSE that it's running on. And then there's a few pieces of information here that are like, okay, what is continuous integration? We want you to run the checks. Okay, the checks is just a unit of work called PyTest where all we want you to do is run PyTest. It is a little bit of a weird syntax and I don't want to delve into it, but it's like, if you just in our repo here have a file, such as, you know, again, hello.py, and all we're going to do is have, you know, a function called sum that simply returns a times b, and then we have a function called testsum, which all it's going to do is assert that sum of 1, 2 equals 3, which it won't. We can run PyTest on that locally, right? And it will fail. But if we say add that file, git add hello.py, adding hello. If we say add this to GitLab, git push origin master, if we add this to our repo we just made, you'll notice there's no pipeline here. There's no little green thing, red thing. And that's because there's no continuous integration processes because we have not defined any. We have not given GitLab any instructions as to what to do. But if we say go and copy what's inside of our .gitlab CI file here, GitLab ci.yml, we'll talk about what a YML file is next week, and I paste that in, now if I add my GitLab CI file, say adding continuous integration capabilities, like that, now when I push that up to GitLab, you'll see that things will be slightly different. I don't know if it'll work. Let's see. So when I push that now, you can see that because GitLab sees this file in the particular branch, it's now trying to run it. So when I go to this pipeline pending, you see here, now I go here, this is one of the checks. So suddenly the file starts to make a bit more sense, right? Because, you know, this is the check stage. So we have this PyTest check, I click on it. This is the actual machine here running, right? And this is all some fancy BS. And then now it's like, all right, let's go. So it runs PyTest, we get this output, it says no test run. Oh, why is that? Why no test run? Well, because the file name's the wrong thing. So like you might think, why is my code not working? Well, because locally we ran PyTest like this. We were like, oh, PyTest hello. But if you just run PyTest, it doesn't pick up on anything because there's no test file. So let's say we rename the file from hello.py to hello-test.py. Now, obviously, you should separate your implementation here a bit, but let's add these two files. And then you see if when I push that, if I go back to my CI demo, it's now running again. And if I refresh the page, it's probably already done. Oh, you know, orange means waiting, queuing, blue means running, and then there's a result. So in this case, it failed. And when I click on it here, you see that it's actually run it for me. So it's literally just like a second computer. You have your computer, you run PyTest, you push it to GitLab. GitLab says, I'm going to go talk to my fancy computer and run these commands. Camille says, if we had an infinite loop, would the pipeline never pass? The pipeline would probably run and it would kill the process eventually. I don't really know how quickly it would. I mean, you could try this out. I mean, please don't you try it out, please, because you'll just make everyone miserable. Oh God, what have I done? I don't know. That's fine. Don't do this. You'll get a timeout error. So, you know, if you come back here, what'll end up happening is you get an error that's like, sorry, this took way too long. So it's queuing, it's running. And then when you open it up, you can actually see it running here. Wait. Did it run? Did I actually push that code? I'm confused. Maybe there's a test time limit. I don't know. Is that the right file? Go check GitLab. See if it's what we pushed. Yeah? I don't know. I don't know why they fail. I mean, that's a great thing. I don't want your while true loops ruining everyone's day. I was surprised that. Anyway, I'm not sure. Never tried it. So that's what the GitLab CI file... Oh, the assert failed. Oh, thank you. Matthew is on top of it. So, you know, if we do this one, don't ever do the same commit name twice. Hello test. Don't do this v2. Git push. Refresh this page, and then it'll pending, running, be running for a while now. So blue means running, and you'll see it'll sit here. Timeout's 15 minutes. Now, I don't know if the runner does things in parallel. I just don't know. I didn't set it up originally. But don't do that, please, because it'll slow someone else's work down. Now, in terms of your repo, you can actually go to the sidebar here, and on this particular little rocket ship, you can actually have a look at the pipelines and the jobs. So the pipelines actually show you every kind of thing that runs. You know, in this case, it's like, okay, here's the first one we ran, here's the second, here's the third, here's the next one. The 3 failed, this one's running currently. You know, if you cancel it, it'll come back as like canceled. And then you have jobs, which are actually like the underlying components of a pipeline that runs. So every time you push code, you're going to run one pipeline, and that pipeline might be made up of a series of jobs. For iteration 2 and onwards, what you're going to see in your GitLab repo is you're going to see us adding to the GitLab CI file a pilot check and a PyCoverage check, which we talk about tomorrow. So your pipelines from iteration 2 onwards next week will actually involve more checks. We'll talk about one of those checks tomorrow, but it will run PyTest, it will lint your code, that'll do a check we'll talk about tomorrow, and all of these checks will be part of your auto marking mark for iteration 2 as well. So, yes, that's what we're doing. That's kind of it, actually. I've talked through all of these slides in a slightly, fragmented way in the last 10 minutes. But that's kind of it. So again, summary, GitLab, you have a GitLab CI file. You can put stuff in it. GitLab will read that file. This is this specific file name GitLab cares about in different Git tools. There's a different file name. And like maybe to give you a bit of an example of like, I'll show you something more practical from my own work is, for instance, we have pipelines that run on our code. I'll show you this one here. I've just got to double check it's not. Yep. So like we have pipelines that we run on our code here, and this is using another Git tool, right? But you can see there's actually more steps here. So some of these steps I won't talk about, but things that are kind of obvious is like, this is like a pip3 install requirements.txt, right? So because the thing is, your runner is just a separate computer. In the case of the 1531 runner, we actually do this step automatically for you. That's why we have the requirements.txt file, because the runner has all of those pre-installed. So in a normal runner, you'll actually have to install all the modules your program uses. We lint the code, you type check the code, you build the code, you test the code, you do some other stuff, right? But this is like what a standard continuous integration pipeline might be. And you can add more to it, though the more you add, the longer it takes. This one took 20 minutes to run. So you think about your PyTest, like this thing takes 20 minutes to run, which can be quite a while, and it can be quite kind of demanding. So sometimes what you might do in bigger projects is you actually won't run all of the continuous integration tests on every single branch. You might only run it when you're about to merge it into master. So, some things that take a really long time, for instance, like 5-10 minutes, you might leave those out of the every branch check because you might want something more rapid whilst you're developing. Now, just to answer some kind of final questions in the last minutes here. I saw some. Yeah, I mean, Blake said, can we add things like pilot and coverage to the pipeline for our project? We'll add them for you. Please don't add them unless you really, really, really know what you're doing, because we'll add them for you for iteration 2. Blake says, how does it know what to do with the output from PyTest? Is that all done on the machine at CSE? So PyTest is run on the machine at CSE, but when PyTest finishes, it actually sends back like a true or false command as to whether it passed or not. So it actually kind of gives a signal. It's like failed, passed, and that's how the pipeline knows what to do with it. Camille talked about the infinite loop, which we discussed. Caleb says, is the Pylint RC file you use custom to the course or just the Google one? I think it's the default one Pylint provides that we might have cut a couple of things out. I can't remember off the top of my head. I'm sorry. But we definitely didn't make it more strict. We either left it or we made a couple things less strict. I don't remember. May Sony 1 says, would the time be reduced if you used a better or faster PC for the runner? Yeah, definitely. More powerful computers will run things quicker. It's a cost trade-off typically in the real world. Like, how much is getting this from 20 minutes to 15 minutes worth in terms of dollars? Don't know. Well, it depends. Are you blocked by this? You shouldn't be, because again, all these commands you can run locally. Just like in your work. Sometimes you can't on more complex projects, but like running it quicker, it's a sanity check. You're not there. It's not there to rely on. It's a sanity check. And Art Smart says, Hayden, do the leaderboard auto tests use all tests that you guys run on for the final auto marking? Yes, it's all the tests. The philosophy we wanted to follow with this was that the mark you see on the leaderboard tells you the mark you will get once you submit your project. Exactly. It's the exact same test. It's just that we don't tell you what the tests are and we only run it 5 times. If all the marks for iteration 1 are too high, we might run it a few less times. Like, it's because naturally this leaderboard is great. We love it. That's why we do it. But it's going to drive marks up quite a lot because we're kind of giving you even more like direction. And we're saying here is more helping hands that normally you would, like you'd catch out groups here that are just doing the wrong thing. You know, normally you'd catch them out in the auto marking. Now there's like more help to get higher. Or we might have to write harder tests. Because to be honest with you, the tests we write for the project are pretty straightforward. Like, we don't test anything crazy most of the time. So, you know, maybe the tests are too simple. We'll figure all that out as we go. But the point is that, like, for this iteration on the leaderboard, it's like everything is what you see is what you get. James says, I know it's only marked for iterations. By the way, while you're here, because we've got a couple minutes left, please leave feedback for the continuous integration lecture. James says, I know it's only marked for iterations 2 and 3, but would it be necessary to lint our iteration 1? No, we're not going to check any of that. We don't care. Obviously, your code should be readable, but your tutor's not going to be like, wow, you had a slight inconsistent style here. Hussein says, are all tests created equal or do some have weightings? No, all tests are created equal, I believe. Masoni1 says, will we be required for 100% code coverage? There is... I'll be really clear with this. There is no code coverage for iteration 1. There is no pilinting for iteration 1. There is nothing you need to be concerned about to do with continuous integration for iteration 1. In fact, I'm pretty sure everything we talk about in week 3 has nothing to do with iteration 1. Yeah. There's a little bit we talk about tomorrow with testing that you might find interesting. You might be like, oh, okay, well, maybe that's an interesting thing I could go and apply to iteration 1, but there's nothing like explicit otherwise. Last couple questions. We'll have to wrap up, everyone, because it's 11:59. Will we release the tests after the iteration is due? No, we won't. We reuse these tests sometimes for different, different terms and stuff. But I'm pretty sure you will actually, like, when you actually get your auto marking back, you will actually see the PyTest output. So you'll actually see the PyTest output even if you don't have the test. So there'll be some hints and stuff. VS Code can do linting automatically. Your alias will have already been sent to your group. If you don't have an alias, go talk to your group. Everyone in your group should check your email. If none of you have it, then you can post on the forum. I sent it like a week or 2 ago, like a while ago now. So go check your email. And if none of you have it, post on the forum. But if I, check, because I will check if I sent you that email is the first thing I do. Do we lose marks there or what? I don't know what that is in relation to. Sorry. Anyway, yeah. That's it. It's 12 o'clock, so I'm going to wrap up. If you have any other questions, please post on the forum. Otherwise, please have a great day, everyone. I'll see you all tomorrow morning. Take it easy. Look after yourselves, all of that. This year's can only get better, hopefully. So, yeah. All right, have a great day. Leave some feedback right there.